Okay, so for this section 5.6, we remember with dealing with the law of sines. The law of sines was useful when we were given an angle-side angle case. Also useful when we were given an angle-angle-side case. So those two situations lend themselves well to the law of sines. We're able to use the law of sines to solve any triangle that was of this form. Okay, we also learned that that the law of sines can be used in the side-side angle case. Okay, but we also have an issue with the side-side angle case because of the ambiguity. And we got to make sure that that we consider two triangles there. Okay. But in all three of those cases, the law of sines worked very well. Okay. Now, in geometry, we learned two other cases for triangle congruence, and we're going to consider those today. So the first one is going to be side angle side case. Okay. So I'm going to give you a triangle, and let's see if we can use the law of sines to solve it. So in this particular case, we're going to say that our A is 10, B is 4, and then angle C is 25. So just like our previous work, we're going to draw a picture first. So if I draw this triangle, my angle C, put that there is 25. Okay, I don't know what the other angles are here, but with that said, if I know that side A is 10, I'm going to make that my side A, which means my angle A would be at the top in this case. And then we'll say my side B is 4 over here. So, like I said, like we studied in geometry, when we were given this information, we have two sides and the angle between. That's the side angle side case. So, the question is, can we use the law of sines then to solve that? We know it's not a right triangle here. That's not any given information that we know. So we can't use our SOHCAHTOA information. So our only option at this point would be law of sines. Okay, however, if we try to set up the law of sines with the variables that we have and the information that we're given, we could say sine of 25 degrees over C equals sine of B over 4. Would be one thing we could write. That would be true. Or we could say sine of A over 10, but the problem with this equation is it has what? It's got two variables. So the law of sines is not going to work in this case because we don't have enough information. Fair enough? Alright, so ultimately, lucky for us, we have another law, which shockingly is the law of cosines. And we can use the law of cosines to handle this particular situation. So what the law of cosines states is the following. Okay, so we can use the law of cosines to find either angles or sides. Okay. We're going to use it to find a side in this case. I want to find side C. Because think about it, if I did know side C, then wouldn't I have only one variable here? And I'm going to tell you right now that the law of sines is easier to apply than the law of cosines in terms of how much work you have to do. So what we're going to try to do here is use the law of cosines once, and then use the law of sines after that to figure out the rest of the stuff that we need. Fair enough? So that's kind of an overview of where we're going to go with that. So what we're going to look at next is what does that law of sines look like? Okay. Well, it ultimately looks like this. Okay. So we're given three different equations. Okay. And all three equations are basically the same equation, and they're just written in terms of the three different sides individually. So I guess at this point your choice would be to pick whichever one has the variable that you're looking for. So in our case we're looking for side C, so if it were me I would write down the bottom one. Okay. Now again, you can use any one you want because they all have side C in them, okay, but it's going to be easier to solve if we use the one with C squared on the left. Fair enough? Okay. So, with that, I'm going to go ahead and write down my C squared equals A squared plus B squared minus 2AB times the cosine of C. And at this point, we can go ahead and start filling in the blanks because we know all the information besides C squared. So A squared is the side across from A, of course, which is 10. Side B is across from angle B, should be 4 squared minus 2 times 10 times 4 times the cosine of 25 degrees. Okay. Right. And at that point, it's just a computation problem because on the right side it's just a number. So if we compute all that and then take the square root, then we'll have our answer for C. So let's go ahead and do that. Once again, 25 degrees, so make sure you're in degree mode. So if we go 10 squared plus 4 squared minus, one thing that I like to do too, and it's not terribly imperative for this problem, but if we're trying to find an angle, okay, I think it's very imperative that we put parentheses around that part. You know, so when you see it in your book or you see it on that previous slide I showed you, okay, there was no parentheses. Okay, but I would go ahead and put the parentheses on there just to make sure that I keep everything straight in terms of the order of operations. Okay, when we find an angle in a minute, I'm going to show you what people generally do to get this wrong. Okay, and it's because usually they mess something up here with the parenthesis part. So again, you don't have to have these on there, but I would put them on there. Okay, if I were you. Okay. So if I go 2 times 4, 2 times 10 times 4 times the cosine of 25. I get 43.495, and of course I'm not going to erase that, I'm just going to take the square root of that so I get my C. And when I do that square root, I get 6.595. Okay. So to the nearest thousandth, that would be my side length. Okay. And before we continue, any questions about the formula or how to apply so far? Okay. Now, as I mentioned, if our job here was to solve this triangle, we would need to find angle A and angle B at this point. True? So what I would do is I'd go right back up to the law of sine sentence that I wrote, okay, and use the C value here that I just calculated. Fair enough? Okay. Could you use the law of cosines to find the other angles? Yes. Okay, but again, it's going to be more difficult to apply. It's going to be much easier to apply the law of sines. One thing that I want to caution you on also, and I've mentioned this before, is that if we're going to use that C that we just found, okay, make sure that you store it so that you don't type in a rounded answer and then have error in your final answer. So if I were you, I'd store that. So store it. Might as well just call it C since that's what it is. So now that we have that value stored, and then if we do the cross product property, we're going to get C times sine of B and 4 times sine of 25. And so if we do the math on that, we're going to get 4 sine 25. Divide that by C, which gives us that. So at that point, we'd have sine of B equals 0.256, etc. And at that point, we can do the inverse sine, just like we did in our previous law of sines problems. And we can get our answer, which is 14.852 degrees. Alright, we're almost there now because we only have one more thing to figure out, and that's angle A. So my question is, what would be best here to find angle A? Law of sines or law of cosines or other? I mean, we could certainly find it using law of sines again if we set up another true sentence, right? But wouldn't we be kind of wasting time since we know that the 3 angles add up to be 180? Right. So at that point, you just go 25 plus your 14 and then subtract from 180, and then you'd have that triangle solved. Okay. All right, so anytime that we have that side angle side case, okay, that's going to be the procedure. We're going to want to use the law of cosines to figure out the missing side. And then once we have the missing side, then we'll go back to the law of sines to find the missing angle. Okay, and once we have 2 angles, of course, then the third is easy to calculate. Okay. How about the question so far? Okay, then the 5th case in geometry for triangle congruence with side, side, side. Okay, we could be given a side, side, side case. And so let's see what happens if we need to deal with that. So we're going to do, I want to look at, there's 2 problems on page 494 if you want to look with me. They give us number 9, A equals 1, B equals 5, C equals 4. Okay. And then in number 11, they give us A equals 3.2, B equals 7.6, and C equals 6.4. And ultimately the job here just says solve the triangle. Okay, so we can use whichever law we choose. But as we saw in the previous example, when we try to set up an equation here with side, 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 okay, we're going to have two missing angles, okay, which means there's going to be two variables in our law of sines. So that means the law of sines is going to be no good. Okay. So what we're going to do instead is, if I draw my triangle here for, I'm going to do the bottom one first. So I'm going to say 7.6 here, 6.4 here, 3.2 here, so at least looks kind of close to scale. So that would be angle B, angle C, angle A. Okay. And so if we try to calculate one of these angles, okay, which if we knew one of these angles, then we could go right back to the law of sines again. So we really only have to use the law of cosines once in any given triangle, which is good news. And so we have to decide which angle do we want to find. And that's completely up to you. You can decide if you want to find either A, B, or C. It's totally your choice. So let's find A. So who can tell me why would I choose this particular version of the law of cosines if I want to find angle A? Anyone? Ultimately, if I'm going to find angle A, okay, what does this have in it? It's got angle A in it, doesn't it? Okay, the other ones don't have angle A, so would there be any other choice if I want to find angle A? No. Okay. All right. So what I want you to see carefully here is the order of the steps to find this angle. As I mentioned earlier, if you do one thing wrong here, it's going to kind of mess up your whole answer. So make sure we're clear on this. If we do our A squared, that's 3.2 squared. B is 7.6. C is 6.4. Minus 2 times 7.6 times 6.4 times the cosine of A. All right, right now I'm going to leave the parentheses off there because I want to show you what I was talking about a minute ago. So once we put in the values, we're going to evaluate the squares first. So make sure the order is important. Make sure we do everything in the right order. So we'd get 10.24 over here. 7.6 squared is 57.76. 6.4 squared is 40.96. And then if we multiply these three together, 2 times 7.6 times 6.4, we get 97.28 times the cosine of A. Okay. So the steps, again, are fill in the blanks. Okay. Evaluate the three squares, multiply the 2 BC part in this case. Okay. And then the next step is going to be to add, because ultimately we want to get A by itself. So let's add these two, 57.76 plus 40.96. We get 98.72 minus 97.28 cosine A. All right, this is the point where people generally, if they're going to make a mistake, this is where it's at. Okay. What people generally do is they do 98.72 minus 97.28. Okay, can't do that. Because remember, these two, if we were trying to add or subtract these two, they're not like terms. Okay, this isn't just 97.28, it's 97.28 cosine A. So are these even like terms? Is it even possible to add them? No. If you did that subtraction, you'd be not following the order of operations because the multiplication has to happen first. Okay, then the addition or subtraction. Okay, so this is why I stressed a minute ago that I would put parentheses around this whole part so that hopefully you'll remember not to do that. Okay. All right. So what we really want to do, though, besides subtract those, is we do want to subtract 98.72 from both sides. So if we go 10.24 minus 98.72, we get negative 88.48, negative 97.28 cosine A. All right. And if we divide this time by negative 97.28, we get 0.90953, etc. equals cosine A. And of course, one job left, and that's to take the inverse cosine of that. And if we do so, we get 24.558 degrees. And that would be our angle A. And once again, once we know angle A, I'm not going to go through the rest of it at this point, but once we know angle A, then we can use that to find angle either B or C. And if we know two of them, of course we know the third. Okay. Okay, questions on any part of that procedure? We have side-side angle, finding a missing angle, the law of cosines. Questions on any of the steps that we did here?